All right, so 6.7 is on graphing and solving quadratic inequalities. Okay, this is like the easiest section in chapter 6. You guys are going to like this. Your homework's super easy too. It will take you like 10 minutes. Okay, so we're going to start out by talking about graphs. So it says a quadratic inequality in two variables is one of these four forms. So you could have y is greater than a x squared plus bx plus c, y is less than or equal to, greater than or equal to. So one of those four forms. Okay, so it's going to involve some kind of shading, just like lines did, linear inequalities. So in this case, I'm going to graph y is greater than x squared minus 6x plus 5. Okay, so when I graph that, I'm going to use a dotted line because I don't have greater than or equal to. Equal to would be that parabola. Okay, so I'm just going to graph the parabola. So I call this the boundary, is y equals x squared minus 6x plus 5. Okay, and you can do this with a t-table if you want to, or you could use some of the skills that you've developed this chapter. So one of the things we've talked about is the x-intercepts, or the zeros, right? So we plug in 0 for y, and we factor. So we'd have x minus 5, x minus 1. So we'd get x-intercepts at 5 and 1. So these are just the points, 5, 0, and 1, 0. So we have those points. So if I was doing a t-table, right, I would plug in 1 and get 0. I would plug in 5 and get 0. So I have 1, 0, and I have 5, 0. Because I have those 2 points, I can kind of see my invisible line of symmetry. Do you guys see where it's going to have to be? At 3. So you can draw this in. I would probably not, though, because it's going to be confusing once we draw our problem. But it's going to be right there. So I'm going to have x equals 3. I could have also done my negative b over 2a. And now I plug in. So if I plug in, I have 9 minus 18 plus 5. So I get 14 minus 18, so I get negative 4. So I have 3, negative 4. Negative 4. So I have a parabola, and I'm going to draw it in as a dotted parabola because I do not have equal to the parabola. So that. And then just like with linear inequalities, I decide where to shade. So I do a test point, and I decide if I'm going to shade above it, or if I'm going to shade that test point or not shade the test point. You could also say, am I going to shade above the parabola or below the parabola? Okay, so if I do a test point, usually the best test point is 0, 0. This is not on our parabola, so we're allowed to pick it. So if I have 0, 0, I'm going to have 0 is greater than 0 squared minus 6 times 0 plus 5. So 0 is greater than 5. Right? It doesn't work. It's false. So 0, 0 is not in the shaded region. Instead, we shade here. Okay. Since it was y is greater than, it ended up being above the parabola. Do you see how that's kind of above the parabola? Kind of weird. All right, so it says using the graph above, what do you think it means if we ask when is x squared minus 6x plus 5 greater than 0? So it's kind of confusing. This is the part of the parabola. So actually on the parabola, so if I went through 1 and 5, so if I actually graph my parabola and it's like a filled in parabola, and I said where is it greater than 0, what I'm saying is when is it above the x-axis? Well, it's above the x-axis on this end and on this end. Does that kind of make sense? Where is the parabola above the x-axis? So it would end up being negative infinity to 1, parentheses, because it's not equal to, union 5 to infinity. Okay, so it's kind of a graphical example, like you can see it through the graph of what we're going to do today. Okay, so we're not always going to graph it out. We're going to do it without graphing. Okay, so let's try the next thing. So we have all of these steps written. You can read all the steps if you want. I'm going to show you a couple examples. You're going to be like, oh yeah, this is easy, I got this. Okay, so let's say I add the 3 over. So I get x squared minus 10x plus 21 is less than or equal to 0. So I always need 0. I'm going to factor, just like normal. So I get x minus 7, x minus 3, less than or equal to 0. If I set it equal to 0, I get what I call critical values. So x minus 7 could be 0, x minus 3 could equal 0. So I have x equals 7 and I have x equals 3. These are called critical values. that's when it's equal to 0. Those go on a number line in the order that they are, right? So I'm going to put the 3 before the 7. Okay, now I'm going to test in each interval to see if things are true or false. So you could go all the way back to the original problem, and you could say, I'm going to test 2. If I try 2, I get 2 squared minus 10 times 2 plus 18 is less than or equal to negative 3, and you decide if it's true or false. Okay, that takes a long time. We don't want anything that's going to take a long time. So what we do is we test our different values. So in each interval, 2, 4, 8, like these different numbers, I'm going to test them in the factored form, so in this form right here. Okay, so I usually do it with a little table. So I put my x minus 7, I put my x minus 3. I want for my result to be less than or equal to 0. So what I was saying is I'm going to pick a number in each of these locations. So like 2 would be a good number, 4 would be a good number, 8 would be a good number. I'm going to test 2, 4, and 8. Okay, if I try 2, when I plug in 2, I get 2 minus 7, which is negative 5. And then I get 2 minus 3, which is negative 1. And I know that negative 5 times negative 1 is a positive 5. Okay, I'm not going to worry about all of those numbers, though. All I'm going to say is 2 minus 7 is negative, 2 minus 3 is negative. And when I take a negative number times a negative number, I get a positive number. It's much faster. All right, 4. If I plug in 4, I get a negative number, right? 4 minus 7. If I plug in 4, I get 4 minus 3, which is positive. A negative number times a positive number will end up being a negative number. And then I try the 8. So I have 8 minus 7 is positive, 8 minus 3 is positive. Positive times positive is a positive. Okay. I wanted where it was less than or equal to 0. Less than or equal to 0 means that I want negative numbers. So I want anything that gives me a negative. That's going to be what makes it true, right? So it's right here. That's my answer. So any number that I would have picked between the 3 and 7 would work. So I could have picked anything. I didn't have to pick 4. All right, so any number in here will end up working. So I shade everything between them. What about the endpoints? What about 3 and 7? What do you think? Filled in or open? That's what makes them equal to 0, right? And since we had less than or equal to 0, we fill them in. Right. So my answer is bracket 3 to 7. Bracket. All right, so same idea. You're always going to get a 0. You're going to factor. You're going to use those as critical numbers. You're going to plug in numbers in each interval. Okay, so on the next one. So I have x squared plus 8x is greater than 9. So I'm going to have x squared plus 8x minus 9 is greater than 0. I'm going to factor. So I'm going to have x minus 1 and x plus 9. So I get x equals 1 and x equals negative 9 as my critical values. I put them on a number line, so negative 9 and a 1. I test in each interval. So I'm going to test a number on the left of negative 9, so like negative 10. I'm going to test a number in between negative 9 and 1, so a good one is 0. I'm going to test a number on the right of 1, so 2. I'm going to have x minus 1, x plus 9. I want my outcome to be greater than 0. So in other words, I want it to be positive. That's what it means, to be greater than 0. They're a positive number. So I test. So when I plug in a negative 10 into my factor form, I have negative 10 minus 1 is a negative number. Negative 10 minus 9 is a negative number. Negative times negative is a positive. Then I try 0, I get a negative, and I get a positive, so I get a negative. Then I try 2, so I get a positive and a positive, so a positive. Okay, so when I am looking for the things that are positive, it's on each end. So it's going to be on this end, and it's going to be on this end. And then my negative 9 and my 1 this time are open. Because I just said greater than 0, I did not say greater than or equal to 0. So your final solution is negative infinity to negative 9, union 1 to infinity. That's it. Yeah.
How did you get, because you said on the little chart there, like it was negative, and then how did you get the positive again?
I multiply. If you have a negative number times a negative number, it will always be a positive.
Mm-hmm.
All right, so this next one has a GCF. So the GCF is -3. So I'm going to pull out a -3. So then I would have an x squared plus 2x minus 3. So I'm going to have a -3, and then I'm going to have an x minus 1, x plus 3. So I'm not gaining a critical value from that -3 part, right? -3 is never equal to 0. So I don't get a critical value from that. I just get it from here and here. So I get x equals 1 and I get x equals -3. Those are the critical values. So I do my number line. I put -3 on the number line. I put 1 on the number line. I test each location. Now, some of you guys can probably do it without doing the chart. That's fine. You can do it in your head and say, if I plug in -4 into that factored form, what do I get? Okay, so my factored form still involves a -3. What you could do, so some people like to do this, is they don't like having the -3. They would rather divide it out on both sides. Do you guys see that? Dividing out by -3. Divide by -3, divide by -3. But what do you have to do if you divide by -3? You have to flip the sign, right? It's an inequality. So you could do that, but don't forget to flip the sign if you do that. So I just leave it in. Okay, so I say I want positives. Okay, so when I plug in -4, 0, and 2, -4, when I plug it in with a -1, -4 minus 1 is a negative, -4 plus 3 is a negative, but I still have that -3. So always at the beginning, I'm going to have a negative from the -3. So I have a negative times a negative times a negative. That will be a negative, right? Now if I try 0, I have a -3 gives me 0. If I plug in 0, I get -1, positive 3. That's positive. And if I try 2, I get a negative, positive, positive, so I get a negative. It should always alternate on these parabolas. If it is not, there's something wrong. As long as you have two critical values, I guess you could say. If you have something that's like x minus 2 squared equals 0, so like 2 is the only critical value, that's different. Okay, it won't alternate. That's when it just touches the parabola, or it touches the x-axis and pops back up. You guys remember those? All right, anyway, so we want positives in the end. So I want in between the -3 and the 1. And then I want to fill in my endpoints because I did have greater than or equal to 0. So I get bracket -3 to 1, bracket. Okay, so now that we've talked about all of these, let's relate it to the graphing. Okay, so on that very first one we did, number 1, what we had was a parabola that we were finding when it was greater than or equal to 0. So we were saying that parabola went through at 3 and 7, right? Think about when it would be greater than or equal to 0. It's an upwards parabola, right? It was positive x squared. It's going to be, or sorry, not greater than or equal to 0. It's going to be less than or equal to 0, right? Because it says less than or equal to 0. It's going to be less than or equal to 0 right here. That's why we had the spot that was in between on our number line, between 3 and 7. Do you guys see it? But then the next one, we wanted when it was greater than 0. So if we had at -9 and 1, and we have an upwards parabola, but it's crossing at those points, it's going to be greater than or equal to 0 on the endpoints. Right? That's why it was one that involved a union. Are you guys understanding this? So the next one is a downwards parabola, and the downwards parabola crosses at 1 and -3. So if we have a downwards parabola crossing at 1 and -3, and we want to know when it's above the x-axis, it's above the x-axis between the two, right? So you're kind of seeing how this is related to the graph. So you can use that when figuring out if it's above or below as well. All right, so next up, number 4. So it's okay if you have fractions for critical values. So this one, factors. We have 2x and x. Let's see, so we need the 5 here and the 3 here so that we get a 10 and a 3 for my outer and inner terms. So I need a positive 10 and a -3. So when I set each one equal to 0, I get my critical values. So I get x equals 3 over 2, and this other one I get x equals -5. So I put -5 and 3 over 2 on the number line. Now 3 over 2 is really just 1.5. Okay. And then I just pick numbers on the left and right, just like normal. So I'm going to pick like -6, 0, and 2. If you weren't sure what 3 over 2 is, which by now I think you should know what 3 over 2 is, but if you weren't sure, you could just plug in something really big, like 100. It doesn't matter. Anything on the right of it. All right, so then I have 2x minus 3 times x plus 5. I want for it to be less than 0. So if I plug in -6, I get a negative and a negative, so they multiply to be a positive. If I plug in 0, I get a negative and a positive. So they multiply to be a negative. If I plug in 2, I get a positive and a positive, and they make a positive. So we want where it's less than or equal to 0, we want negatives out. So we shade in between. So open circle, so your answer is parentheses -5 to 3 over 2. Parentheses. I'll stop there. Guess I need to pass out.